if I give you that those angles are the same. Well, we're going to find corresponding sides. So I'm going to start with the 4. What side of the other figure corresponds to the 4?
The X.
The X. Okay. How about the 8? What piece of the other figure corresponds to the 8?
The 4-inch.
4. If I do 16, that corresponds with
the Y.
the Y. And Z corresponds with
7.
7. So these are 4-sided. We did mostly 3-sided with triangles yesterday, but 4-sided works too. We have all the sides paired up with their corresponding sides. Now remember, corresponding sides just means they're between the same two angles. We need to find a pair where we have both numbers. That pair would be which one?
8 and 4.
8 and 4. Very good. So 8 and 4 are related.
That is direct.
I'm going to find X first. Does X go with the 8 or the 4?
4.
It goes with the 4, so the same figure as the 4. So X goes on bottom. What goes above the X?
4.
The other 4 over here is the corresponding side from the other triangle, corresponds to the X. So we can cross multiply and divide. 4 times 4 divided by 8 gives us that X equals 2. Now I keep the 8 over 4. That relationship still holds, but now I want to find Y. Does Y go on top or bottom?
Bottom.
It goes on bottom because the same figure as the 4 still. What goes above the Y?
16.
16. Once again, we cross multiply and divide. 4 times 16 divided by 8 means Y equals
8.
8 inches. Once again, we'll do 8 over 4. We want to find Z. Does Z go on top or bottom?
Bottom.
Z go on top or bottom?
Actually, we go on.
Z is from the same figure as the 8, so it goes on top with the 8. What goes below the Z? Corresponding side is
7.
the 7. Now we will cross multiply and divide. 8 times 7 divided by 4. Z equals 14. Any questions? Everybody remember how to do the cross multiply and divide part?
Yeah.
Any questions on matching up corresponding sides or setting up the proportion to find missing sides? This still applies even if we have 3-dimensional figures. So this is just a block that has been shrunk. This distance here is 8 inches, 6 inches, and this is 8 inches. If this dimension here is shrunk to, well, let's call it 5 inches. Let's find X and Y. Again, we'll match up corresponding sides. Which side corresponds to the 15 from the other figure?
X.
X. Which side corresponds to the 6?
The Y.
The Y. And corresponding to the 8?
5.
The 5. Well, we obviously have a pair that have we have both numbers for, which is the
8 and 5.
8 and 5. To find X, will X go on top with the 8 or on bottom with the 5? It's from the same figure as the 5, so it goes on bottom. What goes above the X? 15 is the corresponding side from the other figure. So we cross multiply. 5 times 15 is 55. Divided by 8 gives us 9.375. X equals 9.375 inches. To find Y, I'll pause for a second. Looks like people are writing furiously. So to find y, we still go back to the 8 over 5. Where does y go, top or bottom? Y is from the same figure as the 5. It goes on bottom as well. What goes above the y? Corresponding side from the other figure is the 6. So we cross multiply. 5 times 6 is
30.
30. Divided by the 8 is 0.75. I is 3.75. So I was still, even though these are three-dimensional objects, I was just comparing lengths, so I still use the same proportion. What if I have like this? Oh man.
There's the sharp stick in the eye.
And I tell you that this is just a reduction or shrinking of the other. This one has a height of 12 inches. This one has a height of 8 inches. And I tell you that the surface area, this one is 720 inches squared, and I want to know the surface area of this one. Well, what is my ratio of lengths? Well, I only have two sides. It's 12 inches goes to 8 inches, right? That can be reduced to what? Inches cancel out. 12 and 8 both divide by
2.
2 would work, but we could also do 4. Giving us 3 to 2, right? We have a 3 to 2 ratio of lengths. Are we asked to find an area or a volume here?
The area.
A surface area, an area. So we need the ratio of areas. How do I find the ratio of areas from the ratio of lengths? $23.5 hours ago.
Times
Squared, good. Areas are the ratio of lengths squared. So how do I square a ratio? Well, I square each number. What is 3 squared?
9.
9. What is 2 squared? 4. Now, my surface area is 720. Does it go with the 9 or the 4?
9.
It goes with the bigger number, 9. 720 goes there. And we shall cross multiply and divide. Because that gives 320, I believe, square inches. That surface area. Make sense? You look confused, Donnie.
I'm just looking.
Just tired?
No, I took a nap on the couch earlier. We're good.
It happens. I tell you that the volume of this is 864 cubic inches. And I asked you to find the volume of this other one. Well, the ratio of lengths is still the same, right? Still 12 inches to 8 inches, which still reduces to 32. But now we're not looking for areas, we're looking for
Volume, so you want to cube it?
want to cube it. Very good.
I got a quick question. The
Yes.
surface area is like the reduced ratio, right?
Yeah.
Okay. Just want to make sure.
So we cube it. 3 cubed is 3 times 3 times
27
3.
over, is it 8?
2 cubed is 8. Good. So the 864 is going to go with the bigger or the smaller? Bigger. And we shall cross multiply and divide. 8 times 8, 64, divided by 27. I did not plan this out very well. It's going to be really ugly. Oh, it did work out okay. Okay, 256. That's going to be cubic inches because it's a volume. The easy way to tell is you look at the units. This unit was in square inches, so we had to square the ratio of lengths. This unit was in cubic inches, so we had to cube the ratio of lengths. Something to keep in mind. So let's talk about a fictional character
Ooh.
named Donnie.
You've been putting Donnie through a lot of stuff.
Yo, it's fictional. So it's okay.
It's just
I said frictional for a
I'm
second.
nobody.
A frictional character.
Donnie,
Oh no.
was taking a nap on a couch.
That's a really awkward way to sleep, man.
Unfortunately, the people in Donnie's program
Uh-oh.
It's gonna be on the test.
This is gonna be on a
are trying to set
Totally growing down.
a telephone, a utility pole,
man just sleeping outside on the couch.
with pulleys and cables.
Oh,
He's
okay.
on a construction site. He loaded his couch in the back of his truck and decided, screw it.
Donnie is currently sleeping. The couch is set up 60 feet from the bottom of the pole, from the hole.
Oh, we're good then.
But we don't know how tall the pole is.
Uh-oh.
36 feet. I measured it before.
That's true.
This is a fictional pole.
Oh, this is a big pole.
Yeah, this was gonna be bigger than the real life thing.
We don't know how tall the pole is, but we do know that the cable holding the pole snaps,
Uh-oh.
and the pole starts to fall. Does Donnie's family get to collect on his life insurance? Well, how can we tell if how could Donnie have known before he laid down on that couch outside and next to a pole in the rain, if he was safe or not?
Because maybe
Let's say that earlier in the day,
maybe it's
it wasn't raining, it was sunny. And the sun shines down. And of course, what happens? There's a shadow. Let's say this pole makes a shadow that is 56 feet long.
Donnie's
Well,
sleeping.
does
on the
that
couch.
mean that the pole's 56 feet tall?
No.
No. We need to know what angle it's coming at.
All right, to catch you up, Tristan, Donnie's sleeping on a couch. My classmates are putting a pole in.
Yeah.
So Donnie,
That's not-
before he lays down, Donnie's going to stand and he's going to mark his shadow. And let's say Donnie is exactly 6 feet tall. To make it easy.
Yeah.
Donnie's
On the
shadow
inches.
is 5 feet long. So we know that the ratio of height, shadow length, is how much? 6 feet to 5 feet, 6 to 5. So we have that ratio of 6 to 5 describing height to shadow. We don't know the height of the pole. I'm going to call that h, but we know its shadow is
56
6 feet. So what are we going to do to find h?
Cross multiply and divide.
You got 6 times 56
divided by 5.
divided by 5 is 67.2 feet.
Oh, I'm getting crushed.
Oh yeah, you're done.
So Donnie's family is going
No,
to get a nice
because-
little check.
The pole's gonna fall the opposite way. I'm lucky.
You're just getting pulled.
But the line snapped, so then it's just gonna, nope.
Well, the arrow showed it was gonna
You know
fall
what?
that way,
You know
but
what?
I'm pretty sure.
What we didn't say was Donnie's
Yeah.
brother was operating the lift.
Oh,
Operated the scissor. Cut the
So
cable.
anyway,
Like, did you get that problem written down about Donnie?
Yep, crushed.
it's game over, man. There's no saving him. I'm sorry.
Yeah, there is. It's just gonna crush my toe.
let's talk a little bit more about volumes rather than just ratio. By the way, there is a quiz today, but what I'm going to do is I'm going to give it to you at the end. Let's take it home.
All right. if you have good insurance.
So let's talk about volumes and how volumes are calculated. We said that a length is created by taking a point and moving it a distance. The distance you moved is the length of that line, right? We said an area is found by taking that line segment and moving it perpendicular. The area is that original length times that new distance moved, which we refer to as a width. Now let's take that rectangle that's sitting on the ground. Yes, I realize that doesn't look like a rectangle, but it's a perspective. You're looking at it from up above and kind of off at the corner. So it looks like it's kind of skewed, but that's just a rectangle on the ground. And now what we're going to do is we're going to take that rectangle and we're going to move it in a third direction, perpendicular again, like this. What have we created?
The 3D.
It's a box, three-dimensional object. This now has 3 dimensions. It has both a length, a width, and a height. It has a volume. It is called a solid or a 3D solid.
It's
And a 3D solid always has a base. A base was that original shape that we started out with. That was this shape here.
squared.
That was our base. The volume is equal to the area of the base times the distance we moved. That distance we moved is often referred to as a height. Now the word height can be a little deceiving because the distance moved isn't always vertically, isn't always up and down. Well, let's take a look at an example here. Now, if you're having trouble, by the way, drawing those boxes, here's a shortcut. Draw a rectangle, another rectangle offset, connect the corners. So let's say that this here is 14 inches, 9 inches. Now, unfortunately, when we come with a box, the base of it is not really obvious. In fact, any side of this could be the base. The bottom, I can take the bottom and I could slide it up and down to make the shape, right?
Yep.
Or I can take this side here and I can slide it side to side to make the shape, right?
Yep.
Or I can take the front or the back and I can slide that in and out to make the shape, right? Literally, any shape can be the base. So if that's the case, I'm going to make it easy and just take the bottom as the base. The base is not always the bottom. It's that shape that it's moved to create the object, to create the solid. So what's the area of my base? Area with the little subscript base means area of the base. How do I find the area of that?
Length times width.
14 inches times 9 inches, giving us 126 inches squared. How do I find a volume from that?
11.
Area of my base, 126 inches squared, times my height of inches. Well, 126 times 10 is pretty easy. 1,260. What's square inches times inches?
Cubic inches.
Inches cubed, or cubic inches. Not all of our solids are going to be boxes. Again, not all of our solids are going to have the base on bottom. So let's say that this is 8 inches, 15 inches, and 25 inches. The base here is the front of it. This triangle is the base. Why? Because that's the shape that we could pull through the object to create the solid. Does that make sense? If we slice the solid, that's the shape that the slice is going to look like. So let's find the area, the base. How do I find the area of that base?
25 times 15.
Oh,
Oops.
8 times 15.
8 inches times 15 inches. Why did I put it over 2? Because it's a triangle. That's half of a rectangle. It's a triangle. Triangle, every triangle is base times height divided by 2, right? So that is going to be 60 squared. First level side. Any questions over the 60 inches? Volume 60 inches squared times what's my height? 25. Now, that doesn't look like a height. It doesn't go up and down. But the height in these solids is defined to be the distance from where the base started to where it stopped, or just the distance between bases. This shape here is also the shape of the base, right? 25 inches is the distance between this and that, the distance between the bases. So it is 25 inches. Which gives us 1,500 cubic inches of volume. What do you think? Add? Let's say that this is 12 inches, 8 inches, that distance is 6 inches, and let's put this down here at 14.
So is the top smaller, is the back just farther back? Shape.
Well, this is 8 and this is 14, so the back is smaller than the front.
Are we sure that's the back and not the front?
Don't get all this perspective, Jim. So that is the base right there, and that base is a trapezoid. Remember how to find the area of a trapezoid?
No, I just cut it into 3 pieces all the time.
A lot of people do. We take the two bases. Remember, the bases are the two sides that are parallel. That's the 8 and the 14. So 8 plus 14. We add them together. Technically, we average them together. We add them together and divide by 2. Now we multiply by the height, which is the distance between those, the 6. 8 plus 14 is 22.
Divided by 2.
Divided by 2 is 11. Times 6 is 66 inches squared. That's the area of a base. So the volume is going to be what?
Times 12.
66 inches squared times our height of 12. $792. Just keep. What do you think?
It works.
Good stuff?
Yep.
Why do I go through that formula? A lot of people, volume is just length times width times height. That only works for what shape?
Works box, yeah.
Would not have worked for this one. Would not have worked for this one because the base is not a rectangle. Only works for a box or a figure that has the base of a rectangle. My formula, the area of a base times the height, works for any shape, even this one. So this is a cylinder. What shape is the base of the cylinder? Is the circle, because there's one here and there's one here. The other way to look at the base is it's the one shape that's the same on opposite ends. So how do I find the area of my base? Pi times radius squared, right? 8.5 inches squared. How do I find my volume from there? Area of my base times what? 18. Good. So my area by base 78.5 times my height of 8. 1,413 cubic inches. Any questions? We are going to spend at least a couple more classes dealing with volumes, surface areas, lateral areas, all that happy crap. I realized after I made Homework 40, which is what this is based on, that I really put a lot of stuff in Homework 40. It's asking a lot of you to do all of it. So for right now in Homework 40, work on volumes, finding volumes. It asks you to find surface areas. We'll work on that next week. Remember, I am gone tomorrow,
Alright.
so you don't have this class tomorrow.
The,
Work on finding volumes for now. Next week we'll look at surface areas. Also, we have not talked about spheres yet. So you don't have to find the volume of anything that has a round ball. I'll give you guys some time to work here. I'm going to shut off the recording and give you your quiz.
Did you send